So, light fixtures in the ceiling?
Rachel, I'm 3 steps ahead of you. This is integrated design. We're going to talk a little bit about integrated design and what that means. So in simple terms, integrated design means that from the beginning of the design phase to the end of the build and the families moving in, we are recognizing and honoring the idea that that a structure, or especially a residential structure, is a system, and it is the sum of its parts. And so we have to recognize that from the very beginning to the very end when building it.
The notion that the house functions as a system, which is comprised of other systems, is the truth, whether you thought about it ahead of time or not. If the designer is thinking about it ahead of time, certain aspects of the design and the systems and the drawings and the information can benefit the build and ultimately the user, basically resulting in a whole that's greater than the sum of its parts. I think that when integrated design isn't used, or it fails, the result is a building that is with a whole less than the sum of its parts. So we're going to look at some examples of integrated design in this particular build at the Evergreen House, Green New Deal Housing's first zero net energy construction project. And we have a perfect example sitting right in front of us with the air barrier at the ceiling. So let's take a look at the polyethylene air barrier. The interior partition walls, so this is an interior partition wall, where the interior partition wall joins the plane of the ceiling, which is formed by the roof trusses, we want a continuous air barrier and vapor retarder at that level. And what you're seeing here is something very simple that I learned about years ago in classes, which reminded me as a designer to talk with the builders about having that poly on site. Putting about a 18-inch wide strip of poly draped across or just tacked in place over the top of that partition wall as you're putting it into place means that you will have the continuity of the air barrier at that ceiling plane. And later, when it comes time to put the rest of the polyethylene up in place, you have a straight shot at sealing that joint with tape, instead of the other way that I've seen. If this was not done first and all the framing was in place, and we had called for a polyethylene air barrier at the ceiling plane, every single line of the top plate of every single interior partition would have to have that polyethylene turned down and sealed probably with acoustical sealant. That's going to take a lot of time, and it's going to be a messier and probably not as airtight structure when you're done.
Right. So that would be a fragile detail, where this is about as robust as it can be given the materials and the strategy. This is as good as it can get.
So Jay, where you went before, so we're looking at another interior partition here, and we don't see the polyethylene. Where is it? Well, it's rolled up, and it's tucked in and taped to the top plate so that it can connect to the exterior barrier, air barrier of the sheathing. And my understanding is they put this in place, they kind of rolled it up to keep it out of the way. But I love that it's sitting there, it's protected. When the time comes, they will roll it out, they'll connect all the pieces, and then they'll put the rest of the air barrier up in place, tape it, and you'll basically have a continuous membrane forming the air barrier and the vapor retarder. Is it the most
I guarantee
robust?
They did that because they had to go back and do this before, after building the wall, so they had to peel this back a little bit in order to slide that in, and that would be really easy, or easier with that rolled up and anchored in place.
We can see an example where they're joining down at the other side of the mechanical room here. So if we want to take a look at the intersections in place, right through here is just, I think, an ideal example of integrated design at play, with the goal being superior air tightness in the end and durability of this air barrier. We really wrestled with the decision of whether or not to use polyethylene at the ceiling plane. We've seen an awful lot of builders of high-performance homes go with a rigid air barrier at the ceiling. Of course, we went with a rigid air barrier in our framed wall, which is this plywood. And I know you've done this, Jay, where you run, what do you use, like 3/8 or?
I have used half-inch, primarily I've used half-inch OSB. You could also use plywood. Plywood's awesome product, probably better than OSB for this application. But it still has a trickiness to that, because you have to decide, does it connect to this on the top of the top plate? Do you seal against the top plate and butt into the top plate? There are a lot of strategies for a continuous air barrier / vapor barrier in a ceiling. They just all have details that you have to be really fastidious about.
And I think the best implementation of any of them all are going to require forethought. And in a sense, integrated design shorthand is to say forethought. We say, plan ahead. And I think, again, that goes right back to that same concept of measure twice, cut once.
I think another great example of integrated design in this structure is that we know that solar panels are going on that part of the roof. So there are no penetrations on that part of the roof for mechanical stuff. Those are all on this side of the roof. Correct. Again, because we know that the solar panels go over there.
Yep. Another example that you're seeing of integrated design is actually the fact of where we're standing right now, trying to place the mechanical room more central and close to the plumbing, to reduce the runs of the plumbing, make it easier for installation, make the hot water distribution more efficient, and the same thing with the air distribution. So in this space, we're going to have ventilation equipment, and we're also going to have the air handler for the air source heat pump. And so there's going to be a fair amount of ductwork basically connected to the top of this ceiling and then moving through the framing into the adjacent spaces. And we wanted all of that to happen below the insulated ceiling and below the air barrier. It probably took me 15 years, I would say, to get proficient in building science and integrated design. And I'm still learning every day. But we don't have 15 years for this generation of builders to get good with building science and integrated design. We've got maybe 5. So we need to accelerate that. And that means that all of us who have something to share and offer can share that with the next generation of those that we work with. And that includes, absolutely, our subcontractors.
I wish I could act scared, but I can't. That's not a thing I can do.
You could be like, didn't know you were there.
But you're holding the plans.